Looking at this problem, we've got to find the area between x squared and the line 6x minus 6x plus 16. So we're looking at the area inside this part here. Now, again, what we've got to look for is, okay, which is the top curve? Well, that's going to be the line. X squared is the bottom curve. But more importantly, okay, what are our limits of integration? Where they intersect. Now, how do I do that? Well, I solved them simultaneously. So x squared would be equal to minus 6x plus 16. Take everything across, make it equal to 0. Solve the quadratic that it will get. So that's when you're looking like that. That's really the quadratic you're going to solve. And you're going to find that you get minus 8 and positive 2. So it'll come down to x plus 8, x minus 2. And that gives you your limits of integration. So that's what we can put in there. Minus 8 to 2 is our limits of integration. We get our top curve, minus 6x plus 16, and we subtract our bottom curve, minus x squared. And then we just, separate terms, so integrate them. Minus 6x becomes minus 3x squared. 16 becomes 16x. Minus x squared becomes x cubed over 3 with the minus there. And then do the substitution. Substitute 2 in, substitute 3 in, substitute minus 8 in to both of them. And then this is basically a calculator exercise with being a bit careful to give us 166 and 2/3. So again, there's what we've got to do. Find which curves are above and below. Draw it up. Draw a nice diagram, nice and clean. Get our points of intersection by solving the curve simultaneously, because we haven't been given that information when we need it. And then we can start to put that into our integral. Our limits of integration, the top curve minus the bottom curve. We'll see the same thing with the next one. This one's a little bit different because I'm looking at x cubed and 4x, both being odd functions. So when I look at the area here, this area, the same as this area. So our rules can be the same. I could do it, if I was going to do this separately, I'd have to change the ideas, because in this part, between minus 2 and 0, x cubed is the top curve and 4x is the bottom curve. Here, between 0 and 2, 4x is the top curve and x cubed is the bottom curve. I can do it separately, but I'd have to do it in two sessions. Minus 2 to 0, the top curve minus the bottom curve, and 0 to 2 of the top curve minus the bottom curve there. Or I realise that that area is the same because they're both odd functions, and go from 0 to 2 of the top curve 4x minus x cubed and double it. So that's where it's a little bit different, because I've realised I've got that area that's the same again, so I can just double it, save myself a little bit of time and effort. So 4x integrates to 2x squared, x cubed integrates to x power 4 on 4, substitute 2 in, substitute 0 in, that's nicely coming out as 0, which gives me 2 lots of 4, because the area in that part is 4, so double it, we get an area of 8. So use those little tricks and tips where you can. Save you some time and effort. Again, this one here, we see that there's some area above the x-axis, area below the x-axis. It doesn't matter, because we find the area between the curve. If I shifted all these up 9 units, that would still give me the same area, because both curves would be 9 units higher, but exactly the same area. So it won't matter. What I do need to realise, what's the top curve, and where is our limits of integration going to be, where do they intersect. To solve them simultaneously to find where they intersect, we put 2x plus 1 equal to x squared plus 2x minus 8, solve that quadratic, and we come down to x is equal to plus or minus 3. So there's minus 3 where they intersect here, plus 3 where they intersect there. It's not a net case where we can double our area, because it's not it's not got any symmetry there. But we can see that we have got an area between the top curve, the line 2x plus 1, which is above the x squared plus 2x minus 8. So that's what we do, top curve minus the bottom curve. Be really careful about the signs here. Simplifying that down, 2x minus 2x, well, that will go. 1 minus minus 8 gives you a positive 9, and the minus x squared will just be minus x squared there. So that's why it comes down to something nice there. between minus 3 and 3. So we start to integrate it then. So that's going to give us minus x squared becomes minus x cubed on 3. 9 becomes 9x, and I swapped them around but kept the signs the same for what they were. Just makes it a little bit neater. And sub in 3, sub in minus 3, and you'll see that you get a positive answer. You won't get a negative answer. If you get a negative answer, you've done something wrong. So you've got to be a bit careful and go back and check it. Because it should give you a positive answer every time, even though there's some area here that's below the x-axis. Don't panic about that. It's okay because we're doing an area between the curves. This one here, this one you can be really careful. You've got to be really careful with, and realize that the curve in this case, x squared, is above x cubed, which would be above x to the power of 4 and x to the power of 5. The higher the power, the closer it goes to the x-axis to start off with, and then goes up to 1. If you're not sure, try and go on the internet and find a nice graphing program for you, and graph them up and see, because they'll all go through 0 and 1. Anything x to the power of a number goes through 0, goes through 1, but the higher the power on it, the closer it comes down here, and it's actually going to be below. So again, what are we identifying? Well, we can see that it's going through 1 and it's going through 0. There's our limits of integration, 0 to 1. The area between, so x squared's the top curve, x cubed's the bottom curve. Integrate them both, as we've done there. Substitute 1 in, substitute 0, and we get 1/12. But again, we're going to do a quick diagram to make sure we know which curve's the top curve, which curve's the bottom. And we could make mistakes here because people see the x cubed and think that's above x squared because it's cubed and that's squared. Not the case between 0 and 1. After 1, yes it is. But between 0 and 1, the smaller the power, the higher the curve is. So be really careful. This one here, curves between x squared, as normal, and x is equal to y squared. So we can see that there's our area between it. And x is equal to y squared is actually above y is equal to x squared. What we've got to do is manipulate this one to go, well, that's going to be written as y is equal to the square root of x, or x to the power of a half. So we've got to realize that is the top curve, that's the bottom. Again, between 0 and 1, a quick graph would show us that that's going to be the case. Again, solve them simultaneously. Square root of x is equal to x squared. We'll factorize down and give you 0 and 1. So there's our limits of integration. X to the power of a half is the top curve, minus the x squared. That should be just x to the power of 3 over 2 over 3 over 2. The formatting went a little bit out there, which gives you the x divided by 3 on 2 is 2/3. Substitute 1 in, gives you 3 on 2. Then we've got 1 cubed on 3, minus a 0, because you substitute 0 in, it gives you 0. And there's our required area, 1/3. So be really careful identifying which is the top curve, which is the bottom curve, and making sure you get the correct points where they intersect so you can start to find the area between those curves.